Hello everyone, my name is Alexander Zelenin. Today we will try to solve another problems on Hackerrank. Try to learn some algorithms, optimization things and so on. Today my friends not come to the stream, so we'll try to solve more complicated problem. Let's go for medium one for the start and choose some of them. So let's go with this task. Just want to mention one important thing. When you try to solve problem like this or any other software problems and you work in pair with some other developer, or you need to solve this problem on interview, on anything like this, you need to think out loud. So you need to explain everything that come to your mind, the solution that you have on your mind, any options and so on. The reason for this is that it's very helpful for your partner, so he will able to help you with solving the problem itself. It's often happen with interviews also. If you not speaking enough, then interviewer will not able to help you and to find what on your mind and what to suggest and so on. So let's go with this problem, try to solve it, try to explain everything and so on. I will read it and then we will start to solving it. So you will be given a square chessboard with one queen and a number of obstacles placed on it. Determine how many squares the queen can attack. A queen is standing on an end-to-end crossboard. The chessboard rows are numbered from 1 to n, going from bottom to top. One of things that I want to mention initially, that it's go from 1 and not from 0. So if we have an array, we will need to add 1 to all our calculations. Going from bottom to top, its columns are numbered from 1 to n, going from left to right. Each square is referenced by a tuple RC describing the row R and column C, where the square is located. The queen is standing at position RQ and CQ. In a single move, she can attack any square in any of 8 directions: left, right, up, down, and the 4 diagonals. In the diagram below, the green circle denotes all the cells the queen can attack from. So the queen standing at 4-4, and she can move 3 cells to the left, 3 cells to the bottom, 4 to top, 4 to right. And also on diagonals is like the same, that is possible go to side or to top bottom, but looks like it only on the smallest direction. So for example, if the distance to top is 4 cells and to the left is only 3, then on diagonal it will be only 3, 1. So we will choose the shortest distance and use this to calculate amount of possible cells initially. There are obstacles on the chessboard, each preventing the queen from attacking any square beyond that pass. For example, an obstacle at location 3-5 in the diagram above prevents queen from attacking cell 3-5 to 6 and 1-7. Okay, giving the queen position and the location of all obstacles, find and print the number of squares queen can attack from her position. In the board above, there are 24 such squares. We will go to function description a bit later, but initially we will try to think by ourselves how to solve this problem. So the queen standing here, and if we see to this board, we can start by counting in all directions, starting with some of them. Let's go to top first, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then when we go here, there is an obstacle. So we go in every direction and add 1 if there is no obstacle. If obstacle, we switch direction and go to another direction. And we need to go before we stop counting when there is end of the board. End of the board is located if any coordinates is lower than 1, or 1 is the last cell, or greater than 8, but not 8 and 1. 1 will be anyway, but 8 is determining by input values. So we have end-to-end chessboard, so it's not new initially. So let's see function description. Complete the queen attack function in the editor below. It should return an integer that describes the number of squares the queen can attack. Queen attack has following parameters: n, an integer, the number of rows and columns in the board; k, an integer, the number of obstacles on the board. Also, maybe it's possible to optimize somehow. When we already found all obstacles, we can go not only just one by one cell, but just calculate the distance to the edge, so we will able to do it without one by one calculation. But it's like maker optimization. We'll see. Maybe we'll go for this later, maybe no. On most of interviews, you're limited for about 45 minutes. So the main thing that should be done is solve a task. All other things, like optimizations, matter only if you solve the task. If you doesn't solve the task, all other things not matter too much. RQ integer, the row number of the queen position; CQ integer, the column number of the queen position; obstacles, two-dimensional array of integers where each element is an array of two integers, the row and column of an obstacle. Okay, so we doesn't have anything like a map. So we have array. We have array for obstacles. I was initially thinking that we have like two-dimensional array that represents every cell and all cells is marked. But since it's not, I presume that it will be useful to change data format for all obstacles from this two-dimensional array, this one that not represents that's the chessboard, but that represent the coordinates of obstacles itself. We'll see. Maybe we'll able to use this two-dimensional array. I don't know. Maybe it will be easier. Yep. Yes, maybe we can go through. Oh, okay. This I already thinking about optimization, but as I told, optimization is next step. We will get back to this later. The first line contains two space. Input format is not too important in this case, since we have all code to just pass to the function, so we'll ignore this part for now. But constraints is important. What is the size of the chess? The size is larger than 0. That's nice, that then at least we have 1-to-1 chessboard, and up to 100,000. So the maximum size is 100,000 to 100,000, which is very big board. And the amount of obstacles is from 0 to the size of the board. I think there will be like -1, since the queen should stand somewhere and not on an obstacle, I hope. A single cell may contain more than one obstacle. Okay, but if single cell contain more than one obstacle, then it doesn't change anything. Okay, there will never be an obstacle at the position where a queen is located. Yeah. Subtasks for 30% of maximum score. It's only change constraints. So we need to get maximum score, so we'll aim for this one, but this is good starting points. Print the number of squares that the queen can attack from position. Okay. For this one we need to print 9. There is also another sample input. The first 2 rows represent size of the board, count of obstacles, position of queen, and coordinates of obstacles. Okay. First I will start off converting obstacles to another format. So I want to have, right now we have like array. Let me copy this one, here. Right now we have array of arrays that looks like this. And for me it looks very useful to convert it to dictionary, where we will have the coordinates like 5, true, 4, 2, true, 2, 3, true. So we will able to find is cell is but maybe we don't need it. But okay. I see that there is like some possible optimization, but this looks for me useful for now, and I think we will start for this format for now. So let's create a dictionary. Let's call it like this for now. So we will go through an array, and on each step we'll have two coordinates. Which coordinate go first? As there was described. Row first goes row and then column. So row number and column number. Let's call it like this: row and column. So we will assign to, sorry, by some reason let's copy everything. I don't need everything. I want to assign only something like this. So we will assign by row and column. I think it's fine. And also, since the row also may not exist, we need to assign it to itself or to an object. With this, we will do like if it's not exist, we will assign sub-object. So right now we have all coordinates in this format. I hope we'll able to get rid of this later on, but for now that is fine. Also, right now let's try to write code that will count for the empty board, and then we will add logic for checking non-empty cells. But for empty board, the distances will be enough. So I also will prefer to rename these letters to something meaningful. So queen row, let's call it queen row, and queen column. Instead of n, let's have size and obstacle count, like this. As for me, this is more useful. Also, we can split it row by row, so we'll have something like this. I prefer this way of organizing arguments, since as for me it's more readable. We have size, we have queen row and column. Generally, if there is no obstacles at all, then we don't even need to calculate the rows and other things, since it will be like at any position it will be the same output, I presume, because we remove only one dot from each row, right? For example, if we'll here, we'll have like 1, 2, 3, 4, 5, 6, 7, 8, 9. No, I was wrong, sorry. On the corners there will be different calculations, since this cell used like by 3 rows, and in this, if it's not on the corner, then it use it also by all of them. Okay, sorry. There is also 9, so everything is fine. So my assumption was right. So without obstacle it doesn't matter, but let's do calculations like one by one by going until end of the desk. We'll have, let's create an array and call it like directions. In this array we'll have a subarray that will determine in which direction we will move and how it will affect the coordinates itself. So for example, if we want to go to the top, we will have something like this, where we have modifying row number by 0 and column number by 1. Alright? No, then we will go to the right, so it will be like this one, right? So if we modify row number, then we go up. So we will have all possible options here, like yeah, there will be also -1 if we go down. I was for a second thinking that like how we will go and so on. So let's start maybe with -1. Oh, 1 second. -1 like this. And I will also add spaces here to just have some space. So -1, 0, 1. All of options here are 0. Then we will have oh, there is auto formatting. Okay. And then we have something like this on this side, -1, 0, 1, but 0, 0 is like meaningless. It means that we are not moving. Then okay, let's describe all of them by words, like top, oh no, let me add the comments like this one. So it will go down. Let's have here down left. All right. Yeah, down left. It will be like -1, -1. Then we will go left. And to go left, we'll have -1 here and 0 here. Then we will go top left. To go top left, we will have 1 to -1. Then we will go to top. Go to just top, there will be 1, 0. Then top right, it will be 1, 1. And the last one will be just right. So it will be 0, 1. Just right. Okay. All right. Now okay. It doesn't matter. Generally, it's better not to format your code like this in most of cases, so it makes some sense. So we have all the directions, and we will go through every of them, and we will have like cycle inside of cycle to find a proper direction, to move through this direction, and add the amount of possible attack cells. So let's add a variable to count attack cells. Just call it cells. And let's go through our directions. And in direction we will have same like we have previously, row and column. So we go through them. Let's return. We need to return or print. Let's see what we have here. Yeah, we need to just return cells. So we now we need to go through them and add the conditions. Like first we start with the current location. So let location equal to location of queen, like this one. So we just copy queen location, and every time we will go from queen location and not from the like last one. Now we need to write conditions like we modify the location by the direction a lot of time. We need to write, I think, do while cycle. It's used really rare. I didn't remember when I had used it last time. So, or maybe while do. Okay, let me start with the condition itself, and then I will add the cycle to move through every cell. So if we need to check both row and column, let's go with object. I prefer object, it's more readable. Row and column. So, oh. And let's rename it to just lock to have smaller rows. So if location row is equal to 1, sorry, or location row is equal to size, or we have the same with column. So if lock column equal 1, or no, sorry, it's wrong assumption. If we I try to check like everything, we need to modify our location with the row and col, and then see that we don't exceed the everything. So location row, we will be add values current row and lock col. Also I'll add the current column, and then we will check that is it lower than 1, or it higher than size, or the column is lower than 1, or it's higher than size. So okay, then we need to add another cycle to repeat this until we can satisfy this. So Let me do with while initially. I think we can modify it here like this, since we will go to every step anyway. Also can have const here, since it will be anyway linked to the same object. Then that's why we can use constant here, and we not rewrite the value of location itself. We change the value of the items of this dictionary only. So we modify the row, we modify the column, everything is fine, and here we need to add our cells. Initially that looks fine, and I presume that we can run our code now, and we will able to complete like cases without an obstacles. And for obstacles we will add additional logic later on. Let's just check that everything work fine. Okay, it's processing. Okay, while it's processing, maybe it's let's add the logic for checking obstacle itself. So we will do it before we go for the next cell. Okay. Looks like we have cycle that never ends. We need to determine what is the problem here. The problem obviously is sorry, we need to invert this logic. Of course it's like super stupid error. We can modify it only if the logic is fine here. So and also it not looks like not more than 1, more than 0, or less than equal, more than 0, less than equal. Okay, so initially I write code for an error itself. That's fine, that one test was failed, so as I told, the positive was fine, and the one with obstacle is failed. So initially I write a condition to have like stop condition, and not the condition for like opposite. So we need to add the condition to check if there is an obstacle, and if there is an obstacle we stop moving in this direction. So if we have our object called obstacle cards, and we checking row, column, if it's true, then we will return from this point, so it will go to next direction. Let's try to run our code and see what will happen here. Okay, we have a row and column, right? Right. Let's try to understand what is the problem. So we have an error on line 41. On this line, cannot read property 4. Okay, let's add the logging here. When you work on the board, it will be much harder to do like this. So by some reason it's empty. But why it's empty? Let's print obstacles itself. So obstacles is empty here also. Ah, okay, yeah, okay. That was obvious. If obstacles not exist, if a row of obstacles not exist, then we should not check it. So, yeah, so, simple error. Okay. Now we need to understand why our output is less than expected one. So let's return our object with obstacle coordinates and just check that we have proper format of everything. So 2, 4, 5 and so on. We have these coordinates. We have row, we have column. We check if the current column is obstacle. So we are going through this example, right? 5, 3, 4 and so on, like this one. So the one thing that we are going from down to top, but it should not change anything. So we have coordinates of our obstacle, right? 2, 3, 4, 2, 5, 5. Like this one. And when we standing here, let's add also condition. Oh, no, not a condition, but logging when we stop to count. So we will stop to count and want to see at what location. Yeah, we can just print the whole location. Just let's add like this. So we stop at the location 2, 3, 4, 2, but not the 5, 5. Why 5, 5 was ignored? I think we need to print also all of them to take a look. Looks like we go a bit out of time with all the explanations and so on, since I was not in a hurry. Okay, where doesn't go for 5, 5 by the reason of we have this top right and down left. So we have top right conditions 1, 2, 3, 4, 5. Condition number 6. When we let's add another information, like what direction we go right now. Row call and add some arrow like this. So we interested when we go to 1, 1. Initially our queen stand at 3. So we doesn't go to this location, it doesn't matter anyway. 1, 2, 3, 4, 5, 6, 7. Okay, then we need to see that we go to all the directions. When we go to down, we go twice by some reason. 3, 3 and 2, 3. 3, 3 and 2, 3. But on 2, 3 we stop moving. When we go minus 1, 1, minus 1, minus 1, 3, 2, so 3, 2 and 2, 1. Right. Then we go to 0, minus 1. 0, minus 1. Sorry. 0, minus 1, and we have 4, 2. And we doesn't go here, right? Right, we stop here and doesn't add this one. Next we go to 1, minus 1 and have location of 5, 5, 2. 5, 2, this one. And that's all. That's fine. Then we go for 5, 3. 5, 3, this one. Also fine. 1, 1, 5, 4, also fine, this one. And to the right there should be 2 of them, like 4, 4 and 4, 5. 4, 4 and 4, 5. Looks like we doesn't go in this direction, right? Right bottom. Down right. Yes. So how stupid it is to forgot to add the direction to down right. So, but okay, so we're going down and we are going right. So we doesn't have such condition, right? So let's submit our code and check that everything is fine. Yes, usually the simplest thing go wrong. So let's submit code. I presume that we will not get the highest score, or we get highest score. We pass all the tests. Okay, this is not optimal solution, but we pass all the tests, and I presume we got the max score. Yes, we got max score. Let's starting with calculating complexity of this solution, and then thinking about possible optimizations. So usually also if you forgot something like this, the person with who you work or interviewer or whatever We'll try to help you to find out that you miss some direction like this, but generally just check carefully what you're writing. I also have all the comments, but doesn't go through them. Okay. Space complexity and time complexity. Let's start with space complexity. So we will have additional obstacle codes that represent our board. And the space complexity, there will be like square of size. So a square of size is space complexity. The directions for space complexity, it's mean nothing, it's just an array, it's not modified by anything, so it's just one. We doesn't store anything else here, so we have only one object that is same size and doesn't change during time, so it doesn't matter also. So we have space complexity of size and square, or since it's called n, we can tell it like n square, which is not as good at all. I presume it's possible to solve it without just any of additional space using, but let's go to this later. For time complexity, we will go through all obstacles, and we have obstacle count, so it will be obstacle count since we do it once. Like for every obstacle count we add one object. For this one, for assigning variable is 1, it's nothing. For directions, we have some amount of directions that fixed one, so fixed one means that it's 1, and go through all of this direction until end of board. Generally it means that we go through all board in all directions. So the maximum amount of cells we move is horizontal size, vertical size, and diagonal size, which is like the same to horizontal and vertical ones. In this case, of course, because it's we move on diagonally the same way. So looks like it will be just time complexity. I had write it like this. I have no idea, like variable. It will be equal to size. So it will be not exactly like size, but like 1, 2, 3, 4 times like size, for 4 times size, but since we drop constants, it will be equal to size. Only going through this one. And then, no, sorry, it was for this condition, of course. No, it was combined. Right. So direction itself that we're going through this, it's just another multiplier like 8. So it doesn't matter. Sorry, 9. Again, same error. It's not 8. We have 9 directions. 9 of size, and like that's all. That's all of time complexity. So we need to combine this complexity. What we have obstacle count and size. So time complexity will be obstacle count plus size. All right. All right. So it depends on count of obstacles and on size itself. Yep. Now we can think how we can optimize it and what we can do with that. First of all, I presume that we can reduce memory usage, and it's instead of going through all cells and all obstacles. No, through all obstacles we need to go anyway, but we can go through them and see if they are on the way of queen and add them only in this case, or not add. So the first thing that how we can optimize is to add obstacles only if they are on the way of queen. So for example, we will not add this obstacle since it's meaningless. Then the maximum space complexity will be size, not the size square, which is also nicest for me. So this first possible optimization. Second possible optimization, that we can try to find the closest obstacle to the queen. Like we can presume that we have in all directions like sum of obstacle, like this one, this one, this one, this one, this one, and so on. And when we go through them, we just move them closer to us and finding the nearest one. So when we find the nearest one, for example, here will be like this one will not move, this one will not move, and so on. With this approach, our space complexity will be like 1. We will not use any additional memory. We will use like 9 of additional cells, but it doesn't matter. So it's possible will be 1. And we will go through all obstacles here. And the size by itself, also, if we will have coordinates of nearest one, we will able to calculate the difference between the nearest obstacle and queen. And with this, we will able to do it with just a formula. We'll still go through all obstacles, but there will be no size, there will be like 1. So possible time complexity will be just obstacle count. I think I write it wrongly, but that's fine. So we go a bit out of time right now. If anyone want to see the optimized solution for this, please write the comments and I will write optimized version of this. Thank you for watching. Have a nice day and good luck.